In this video, we're going to look at some limit problems. So the first one, limit as x approaches negative 2 from the right of 2 over x plus 4. So let's draw a graph of this function, calling this f of x. So what does this look like? 2 over x plus 4. Well, we know at negative 4, the denominator would be 0. Okay? That's going to be a vertical asymptote. This is a hyperbola. Okay? So it looks like this, with an asymptote at negative 4. Okay, and so for these problems, the first thing you want to do is you want to make sure that the point that x is approaching does not make the denominator of the limit 0. So negative 2, if I plugged in negative 2 here, I would not get 0 on the bottom. So negative 2 is fine, right? Negative 2 is just this point on the curve right there. So what the limit is asking me is, if I started over here and I approached negative 2 from the right, what value am I approaching on the curve? And that's just the value of the curve at that point. There's nothing really special going on at negative 2. There's no big jump like at negative 4. So what this limit equals is just f of negative 2, right? F of negative 2, I can just plug in negative 2 to this expression. So that's going to give me 2 over 2, and that's 1. Okay, so 1 is the answer. Let's move on to the next problem. Limit as x approaches 2 from the left of x plus 4 over x plus 2. So now we're not going to draw this one, we're not going to graph this, but we're going to think of the same logic. We're going to look to see if this point that x is approaching makes the denominator 0. Is there anything interesting or special happening at x equals 2? Well, at x equals 2, the denominator would be 4, which is not 0. So there's no discontinuity, right? So if this is f of x, this limit is just equal to f of 2. It doesn't matter what side we come in on, because there's no discontinuity. We can just plug in 2. So we get 2 plus 4 over 2 plus 2, which is 6 over 4, or 3 halves. Okay? That's the answer for this problem. Next problem. Limit as x approaches negative 2 from the right of 2x plus 4 over x minus 2. Okay, so same logic. Does negative 2 make the denominator 0? No. So we can just plug in negative 2. This is equal to f of negative 2. That's 2 times negative 2 plus 4 divided by negative 2 minus 2. Alright, so this is negative 4 plus 4 on the top, which is 0, over negative 4 on the bottom, and that's equal to 0. Okay, so this limit equals 0. So you might think in general it doesn't matter what side you come in on, but that is not true. So let's do this example. We're going to do two different limits. Limit as x approaches 2 from the right of 2 over x minus 2, and then the same function, but the limit as x approaches 2 from the left. So let's graph this one. Okay, this is a hyperbola. So what value makes the denominator 0? It's positive 2. Okay, so we're going to have a vertical asymptote there. And the hyperbola is going to look like this, right? And we're calling this f of x. What's inside the limit? Okay, so limit as x approaches 2 from the right. Okay, so you can imagine you're at a point to the right of 2, and you approach 2 from the right. Where do you go on the curve? You go up and up and up, really high, right? You get up higher and higher, and you approach what number? Positive infinity. If you approach 2 from the right, if you were an ant on the curve crawling along, you would crawl up and up and up towards infinity. Okay? What about if you approach 2 from the left? So a number to the left of 2, and then you approached 2. Well, that's the opposite. Now you're going down and down and down, lower and lower. So that one approaches negative infinity. So it does matter in some cases which side you approach on. It matters in those cases where there's a big break in the graph. See, at x equals 2 here, there's a huge break in the graph. You have to go from all the way down here and then jump all the way up here. If we were trying to find the limit at x equals 1, the right and the left limit would be the same thing because there's no break at x equals 1 over here. There's only one break at x equals 2. Okay, next problem. Limit as x approaches infinity of 2x plus 4 over x minus 2. Okay, so for these x goes to infinity, x goes to negative infinity problems with polynomials, you want to find the highest degree on the numerator and the denominator. The degree is the exponent of the x terms. So the highest degree on the top is 1, just x to the 1. Same on the bottom, it's also 1. And what you do is you essentially just cross out all of the terms that are not attached to that highest degree. So on the top, we're going to keep the 2x, but we're going to get rid of the 4. The 4 isn't attached to x to the 1, only the 2 is. Okay, and then on the bottom, we're going to just keep the x, and we're going to get rid of that negative 2. So in your mind, you can think like you're crossing out the terms that are not attached to the highest degree term. I wouldn't cross this out if you had a test or a homework, because your teacher might not accept that as a proper way of writing it. I would write equals limit as x approaches infinity of 2x over x, because these things are equal, right? So then this is the limit as x approaches infinity of just 2, right? These x's cancel. And the limit as x approaches infinity of 2, well, 2 doesn't have an x in it. 2 is just 2, never changes, right? Doesn't matter where you are in terms of x, that is just 2. So this limit, while it might look complicated, is just 2. That's what this function approaches as x gets larger and larger. Okay? One more problem. Limit as x approaches negative infinity of 4 over x minus 2. Okay, so here, on the top, just a number, and on the bottom we have an x. Okay, so what we want to think is that this is going to approach some number, right? It's just 4, but the key is that it's just a number over big number. This gets larger and larger on the bottom. So if we had some number, say 1, and we divided it by 10, and then we divided it by 100, and 1,000, and 10,000, these numbers are getting smaller, right? They're getting closer and closer to 0. So anytime you have a number over something that's getting larger and larger, it's getting closer and closer to 0. So this limit is equal to 0. And another way you could think about it is you have the limit as x approaches negative infinity of 4 times x to the 0 divided by x minus 2, right? So x to the 0 is 1, so that would be 4 times 1. This is just another way to write it so that you have an x term to look at. And here you have an x to the 0 on the top and an x to the 1 on the bottom. So if the degree, which is 1 here, of the bottom is greater than the degree of the numerator, then that means your limit is approaching 0. So I'll write that here. If the degree of the denominator is larger than the degree of the numerator, then in general, your limit goes to 0. Okay?